Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers OCR Paper 5. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find the link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Question 1. Describe the correlation shown in each of these scatter graphs. Where there is correlation, state the strength. Okay, so we've got two things to give here, correlation and strength. Okay, so in this first diagram, there isn't correlation there, is there? They're all kind of scattered all over the place. There isn't a pattern to it. You can't see a line through the data. So I'm going to say that on this first one, there is no correlation. Okay, on the second one though, we've clearly got some correlation going on here, haven't we? All these points are kind of marching down the page like that. So when you've got the kind of line of best fit sloping downwards from left to right, we call that negative correlation. Which means as one increases, the other one decreases. And look, they're all kind of hugging the ruler pretty close, aren't they? I'd say that's very strong. So I'm going to say that it is strong. Okay, so I've given the correlation and I've stated the strength, so I think we're good. Let's move on. Question 2. Tom invests £2,000 at 5% per year simple interest. How much interest has been paid after 6 years? Okay, now note this is simple interest, not compound interest. We are not putting the interest into the account and then in the second year calculating the interest on the original amount plus the previous interest. It's just going to be the same amount each time. So if 100% of something is £2,000, then what's that? 10% would be 200, 5% is going to be 100. Okay, so that's what 5% interest would be. Now we're going to apply that 5% interest 6 times over because we've got 6 years to do it. So our amount, how much interest has been paid after 6 years, is just going to be 6 lots of £100, isn't it? Which is £600. Part B says Tom receives a 20% wage increase. His new weekly wage is £360. Calculate his weekly wage before the increase. Okay, so with percentage questions I often do these triangles, FOM, just to keep track of what I have to multiply or divide by what. So F stands for final, O stands for original, M stands for multiplier. You can apply it to all sorts of percentage questions. So then we just need to go through and work out which is which. So he receives a 20% wage increase. His new weekly wage is 360. We want to work out his weekly wage before. Okay, so final
is what it was at the end. So that's going to be his new weekly wage, isn't it? So that's going to be 360. The original, well, that's what we're trying to find. His weekly wage before the increase. And then the multiplier is going to be the 20% increase, isn't it? But remember, we start with 100%. So if we increase it by 20%, we're now at 120%, which is a multiplier is 1.2. Okay, so now we cover up the thing we want to find. So I want to find the original, and then that tells me what to do with the other two. So using my little triangle, original equals final over multiplier. In other words, it is 360 divided by 1.2. Okay. Okay, to make things a little bit easier for ourselves, I'm just going to multiply top and bottom by 10. So that's 3,600 divided by 12, because it's a non-calculated paper, isn't it? I haven't got a calculator to tap it in. So 12's into 3,600. Well, 12's into 36 go 3 times, and then I've got 2 extra zeros, so it's going to be 300, isn't it? £300. Question 3. Demi gives her dog 2/3 of a tin of food each day. Work out the smallest number of tins of food that she needs to feed her dog for 10 days. Okay, so number of tins is going to be her daily amount, 2/3, times the number of days, and isn't it, times 10. So 2/3 times 10, well, I can't divide 10 by 3, so it's not going to be a nice number. I'm just going to kind of merge, multiply top with top, bottom with bottom, like that then. So I'm going to do, I'll rewrite that as 20 over 3. Okay, so how many 3's go into 20? That is, well, it's a little bit shy of 7, isn't it? It's 6 times, 6 3's 18, so that's a remainder of 2. So it's 6 2/3. So what's the smallest number of tins of food that she needs to feed her dog? Well, you can't go and buy 2/3 of a tin of dog food. You have to actually going to buy 7, haven't you? So that's going to be 7 tins to the nearest whole number. Question 4. Adil, Kate and Rebecca share £160 in the ratio of 2 to 5 to 3. How much does Rebecca receive? Okay, so within these questions then we need to work out how many shares there are altogether. And we can do that by just adding the ratio bits together. So 2 plus 5 plus 3. That tells me that there are 10 shares altogether. Okay, now if there are 10 shares and we're sharing £160, then each share is going to be 160 divided by the number of shares, 10. So that's going to give me £16 per share. Okay, and then we've got in the ratio of 2 to 5 to 3 to start with. So scaling that up then by a factor of 16. That means that Adil is going to get £32. Katie, sorry, is going to get £80. And Rebecca is going to get 3 lots of 16, which is 48. Now I've done a bit more work than I need to do here, but it's good practice just to double check your 3 amounts actually add up to what you started with, and 32 and 18 and 48 does add up to 160. So I'm feeling pretty confident that I've got my answer right. So £48 for Rebecca. Now Katie says she receives 60% more than Rebecca. Here is her reasoning. I receive 5 parts and Rebecca receives 3 parts. 3/5 is 60%, so I received 60% more than Rebecca. Explain what is wrong with Katie's reasoning. Okay. Well, I think she's got it the wrong way around, doesn't she? She received 5 parts and Rebecca receives 3 parts. Actually, she's received 5/3 of what Rebecca has received, hasn't she? Okay, so 5/3 is 3/3 and an extra 2/3. So she's actually received an extra 2/3 on top of what Rebecca has received. Okay, and 2/3 is, as a percentage, is, well, it's going to be 1.66 reoccurring, or 166 recurring, 167%. Okay, so she's actually received an extra 67%, not an extra 60%. So what is wrong with her reasoning? Well, I suppose we could say she's got the fraction upside down. Part 2 says, complete the following to give the correct percentage. I received 5, well, that's what I just did, isn't it? I received 5 parts and Rebecca received 3 parts. So 5/3 is equal to 167%. So I received 67% more than Rebecca.
Question 5. ABC is a triangle. Part A, construct the locus of points inside the triangle that are equidistant from BA and BC. Show all your construction lines. Okay, so BA this side here, BC this side here. Now the locus of points inside the triangle that are equidistant from B and A, that's going to be the angle bisector between the two of them, isn't it? Okay, so I need to draw an angle bisector of BA and BC. So I'm going to use a compass to do that. Always a good idea to keep a little short pencil in your equipment for these sorts of things. Okay, you want a nice short pencil so that when you're twirling your compass around, it's not constantly bumping into your hands. Okay, so what we're going to do is we're going to put the point at B, that's where the angle is that I want to bisect, and I'm going to draw an arc that cuts both arms, so cuts there and cuts down here. Okay, and then move the compass to the points where I just did the cuts and draw 2 arcs. Oops. Like that. We should form it, show it forms like a little cross. Okay, and then we're just going to join up B to the center of those 2 arcs that I made like that, and that is going to be my angle bisector. Okay, if you've got a protractor with you, you might want to just double check that that angle there and that angle there are the same, but I'm presuming that I've done a good job of my constructions. Right, then indicate the point on the locus inside triangle which is 3 centimeters from A. Well, 3 centimeters from A, I need to set my compass to 3 centimeters. Okay, and I've reproduced this paper, so I'm not sure it's exactly at the same dimensions as OCR intended. Okay, so if I draw a circle based on that, on my reproduction at least, it's only going to cut in one place. It's going to cut here. Okay, so the point on the locus inside the triangle, which is 3 centimeters from A, is just that point there, isn't it? That's the point I'm looking for. Okay, so that's it. That's the point I'm after. Question 6. A clock chimes every 20 minutes. A light flashes every 8 minutes. The clock chimes and the light flashes together at 8 o'clock. How many times between 8 and 12:30 will the clock chime and the light flash together? Show your working. Okay, now this is actually like a lowest common multiple question if you think about it. Let's take the clock first off. So it chimes at 8, okay, and then 20 minutes after that. So how many times is that going to chime between 8 and 12:30? I think I'm just going to list them out until I get a feel for it, because I actually don't think it's going to be that many. So that's 3 times an hour then, isn't it? So then 9, 20, 9, 40, 10, 10, 20, 10, 40, 11, 11, 20, 11, 40,
12. I run out of space, and then it's 12:20 as well, isn't it? 12:20. Okay, so obviously this one at the top doesn't count because we're counting it at 8:01, so that one is too early. So how many times it chime? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. Now, what about the light? The light flashes every 8 minutes. Now, I'm going to start off writing these down. I probably won't do the whole thing because that's quite a lot I'm going to have to write down, and I'm a bit lazy. So it does it at 8. So the next one is going to be 8:08. I might just do an hour because then it's going to be will it be the same? Well, let's see. 8:16. Then it's going to be 8:24. Then 8:32, then at 8:40, okay, then at 8:48, then at 8:56, then no, it won't chime on the hour. It'll go to 9:04 then, won't it? And then 9:12, 9:20. Okay, so where's it chiming together then? So 8:40 I noticed there, look. So it chimes at that one. And then the next time it chimes will be at 9:20 then, won't it? Okay. So notice it's chiming every 40 minutes apart, isn't it? And that isn't surprising because 8 and 20 both have 40 as their LCM. So the LCM of 8 and 20, that's going to be 40, isn't it? It's every 40 minutes it's going to be chiming together. Okay, so every 40 minutes after that then it's going to be chiming here, 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 here. Okay, so how many times is that? It's 1, 2, 3, 4, 5, 6. It's going to chime 6 times. 6 times together. Question 7. Shape A is similar to shape B, and we need to work out the value of H, which is the one that is here. Okay? So when you've got shapes that are similar, all the sides are in the same ratio. So if we can find any pair that go together, we can work out what that ratio is, and we can apply it to any other pair that we've got. So these two go together. Okay? And these two go together. So if we can work out the ratio between 5.5 and 16.5, then we'll know this, it's going to be the same as the ratio between those other two. So we're going from B to A. So if you think 5.5, if you multiplied it by 3, you'd get 16.5, wouldn't you? So going back the other way, we're dividing by 3, aren't we, to go from there to there. So 5.5 is a third of 16.5. So going back this way as well, we need to find a third of 7.5 then, don't we? So H is going to be 7.5 divided by 3. 3 is into 7.5, that's 2.5, isn't it? So 2.5 centimeters is H. The diagram shows two views of a solid made from 14 1 centimeter cubes. We've been given the front view and the rear view. And on the centimeter grid below, we need to draw a plan of the solid. Then there's two ways of thinking about what a plan is. You can either think, you know, if you imagined this to be like a stamp, and you put ink on the bottom, and then you made a stamp of it on the paper, that shape would be the plan. Another way of thinking about plan is it's like an aerial view. So if you were kind of flying over the top of it and looked down, what would the shape look like from above? So both are going to give you the same thing. You're going to get a shape which is well, you can see you're going to get 4 cubes going in this direction along here, and then we're going to get 1 down here, oops, 1 there, and then 2, 2, 2, and then 3 along that side there, aren't we? Okay, so we're going to just recreate that on our grid here. So those 4 along the top then, this 4 here, I'm going to draw along here. Okay, and then I've got my 1, to 2 part. So it's going to come down here, and then it's going to come across 2 and down 2. So across 2, down 2. And then I'll go along 2 up here, and then 3 back to where I started from. Okay, so that's my plan view. Right, work out the smallest number of cubes that will be needed to be added to this solid to make a cube. Okay, well, if it's a cube, all the sides are the same, aren't they? Okay, so it's going to be, well, the longest side along here is 4, isn't it? So if you're going to make it into a cube, you would be adding all these cubes along here and then building it up 4 layers as well. So you would have 4 times 4 times 4 cubes all together to make a cube of side 4, which is 64 cubes. Okay, and we were told in the question how many cubes there were, weren't we? It told me that there were 14. Okay, so if I've got 14 and I need 64 cubes, I'm going to need another 50 then, aren't I? So cubes required. That is going to be 64 minus my 14 that I've got already equals 50 cubes. Okay, so that's my answer. The smallest number of cubes needed to be added would be 50. Question 9, rearrange this formula to make x the subject. Okay, so I've got the x's over here, isn't it? So I just need to cross multiply. I'm going to take this 5 and it's going to cross multiply up here. This 2 is going to end up down there, isn't it? So it's going to end up as being x equals 5y over 2. Okay, so that's my rearranged formula, x equals 5y over 2. Part B says 5x minus 6 equals 3x plus 13. I need to solve it. So I'm going to collect x's on one side, so let's subtract 3x from both sides. They're going to cancel there, look, and it's going to leave me with 2x minus 6 equals 13 on this side. And then I'm going to budge that 6 over to the other side by adding 6 to both sides. That's going to give me 2x equals 19. And then finally, I'm going to divide both sides by 2. That's going to give me x equals 19 over 2. What's that? 9.5, isn't it? 9.5. So that's my answer, 9.5. Question 10. Danny sells pens and notebooks in his shop. On Monday, he sold 5 pens and 8 notebooks for £44.50. On Tuesday, he sold 10 pens and 3 notebooks for £37. Work out the cost of a pen and the cost of a notebook. Okay, now this might not look like it straight away, but what we've got here is a pair of simultaneous equations. We've got 5 pens and 8 notebooks equaling £44.50, and we've got 10 pens and 3 notebooks equaling £37. So if I let P be the number of pens and N be the number of notebooks, I can rewrite those as 2 simultaneous equations. I can say that 5P plus 8N equals 44.5, or 10p plus 3n equals 37. Okay, so looking at that 5 and the 10, I think probably the easiest thing is to take the first equation and double it up then, isn't it? So if I take this one and I multiply it by 2, it's just going to give me, I'm just going to write underneath for expediency, 10p plus 16n equals 2 lots of 44.5, 89, isn't it? 89. Okay, and then what I'm going to do is I'm going to subtract my new equation from equation 2, or the other way around. I'm going to subtract uphill, if you see what I mean, because the numbers are bigger on the bottom. So 10p take away 10p, they're going to cancel each other out. 16n take away 3n, that's 13n. And 89 take away 37, what's that, 52? So if 13n is 52, so n is going to be 13 into 52, goes 4 times, doesn't it? Okay, so then let's work out the price of notebooks then. So we can do that by just subbing into one of our original equations. I'm going to sub back into equation 2 because that one looks about the nicest. Substitute into 2. So if n is 4, so what we get, so we're going to get 10p plus 3 lots of 4, that's equal to 37. So 3 4s are 12, 12 taken away from both sides would give me that 10p is equal to 25, making p equal to 2.5 or £2.50 then, isn't it? Okay, so a pen then is worth £2.50, and an, oh sorry, I did that the wrong way around. No, I didn't. So a pen is £2.50. That's why it was an expensive pen, because it was a notebook. It was £4. Question 11. The diagram shows triangle ABC. D is a point on AB such that DB is equal to 6 centimeters. BC is 10 centimeters. Angle CAD is 30, and angle BDC is 90. Work out the ratio of lengths of AC to the length of DB in its simplest form. Okay, I always just go through and double check that all the information written up here is in the question. So is it got DB is equal to 6, that's on the diagram. BC is 10, that's there. CAD is 30, that's there. And angle BDC is 90, that's there as well. Look. Okay, so because sometimes there's some information in the question that's not on the diagram. So just make sure it's all there first. Okay, now work out the length of AC compared to DB. So where is AC? So I need to work out this length here compared to this length here. Well, I know DB is 6, but I don't know AC at the moment, so I need to find that out. But the only thing that I know in triangle ADC, the left-hand triangle, I only know the angle, don't I? So if I want to find that length, I'm going to need to know something else in that triangle in order to do it. Now, luckily in my other triangle, triangle BCD, the right-hand triangle, I know two things. I know the two sides of those. So from those two sides, I should be able to find the kind of side between them, the communal side. And once I know that side, then I've got two pieces of information in my other triangle, which I can then go on to find the length. So basically what I need to do here is find the mid-length first and then see if I can use that to find the length AC and compare. Okay, so quite a long question, this one. So first off, let's use Pythagoras theorem in this first triangle here then, because I've got two sides and I want the other side. No, it's not the longest side, it's the shorter one. So if I'm using c squared equals a squared plus b squared here, I'm actually going to rearrange it then, aren't I, to find the shorter side. So a squared equals c squared minus b squared here. That's what I want to apply. So putting in our two values from our triangle, then that is 10 squared minus 6 squared. 100 take away 36, which is 64. Okay, so then, well, that makes a equal 8 then, doesn't it, if I'm going to square root that. Okay, so that means that side there has got to be 8. Okay, so now I know CD and I know the angle. I should be able to work out AC. Now, when I know a side and an angle and I want another side, that is trigonometry, isn't it? So I've got what sides? I've got the opposite. I want the hypotenuse. I don't have the adjacent, not interested in the adjacent. So which ratio is about the opposite and the hypotenuse? Well, using SOHCAHTOA, SOHCAHTOA, I know which one is about SOH. It's SOH, isn't it? Sine equals opposite over hypotenuse. Sine of an angle is equal to the opposite over the hypotenuse. Okay? So subbing in what I know, what do I know? I know the angle. Sine 30 equals, I know the opposite, it's 8. The height, that's the length, CA, isn't it, or AC? That's the side AC that I'm trying to find. Okay, so I want to find AC, so let's rearrange that then. So AC then is going to be 8 over, I'm just basically going to switch these around. I'm going to cross multiply these two around, so they're going to switch around. So it's going to give me AC equals 8 over sine 30. Okay. Now, don't have a calculator here, but luckily I do know what sine 30 is. It's one of our exact values that we need to know. Sine 30 is a half, isn't it? Okay, so 8 divided by a half, that's the same as 8 multiplied by 2 then, isn't it? Flipping the fraction over and multiplying instead, it's going to give me 16. So AC then is going to be 16. Okay, so now I know AC is 16. I know DB it's 6, so then I can look at the ratio of their lengths now then. So the length of AC to DB is going to be 16 to 6. What's that in its simplest form? Dividing both sides by 2. I'm going to get 8 to 3. Now 3 is prime. I'm not going to get any lower than that, am I? So that is going to be my ratio in its lowest form, 8 to 3. Question 12. A tank in the shape of a cuboid rests on the horizontal surface. The graph shows the depth of the water in centimeters in the tank over a period of time. So you can see that the water in the tank is lowering. What fraction of the water is left in the tank at 12:30 p.m.? Give your answer in its simplest form. So where is 12:30 p.m.? So 12:30 p.m. is going to be halfway between 12 and 1, isn't it? Which is going to be here. So using my ruler and drawing up to the curve, when I get to the curve, bounce and go along the other direction. Depth should be 20 at that time. Okay, so at that time there is 20 centimeters left. What is that as a fraction then? So I've got 20 centimeters left. I did have 160 centimeters. So cancelling that fraction down, get rid of the zeros first. 2/16 is the same as 1/8, isn't it? So I've got 1/8 of the water left. Okay. So that is 1/8. Now this is how Mike worked out the average rate of change in the depth of the water per hour between 10 and 2. He's done 160, which is the capacity of the tank, divided by 4, the time between 10 a and 2. What errors he made? Okay, well, his method would have been totally fine if by the end of the 4 hours there was 0 left in the tank, in which case all of it would have evaporated or leaked out, whatever it's doing. But actually you can see there's a little bit left in the tank still at that time. So at time 2 you can see that actually there's what, 10 centimeters worth of water still in the tank. Let's just draw that on. So there's actually 10 centimeters of water left remaining in the tank after 4 hours. So to say that 160 centimeters has disappeared is wrong, isn't it? Okay, it should have been 150. So what error has he made? Well, it should be 160 minus 10, 150 divided by 4, because what would be 150 divided by 4? Let's just finish it off, might as well. It's going to be 37.5, isn't it? So yeah. So what error has he made? There's still water in the tank. Question C, Mike estimates that the rate of change of the depth of the water at 11 a.m. is 45 centimeters per hour. Is his estimate reasonable? Show your method. Okay, now rate of change of a graph is the same thing as its gradient, but we've got a sloping graph here. It's not a straight line, so its gradient is going to be changing constantly. So at 11 o'clock, 11 a.m., at this point here, let's just draw the point on that we're talking about, this point here. What is the gradient of the line at that point? Okay, well, we can do that by drawing on a tangent to the curve at that point. And to draw a tangent, you've got to take your ruler and just kind of push it up and nudge it up against the curve in such a way that, you know, your gap on this side here, look, I can't draw there because it's too close to the ruler. So basically the gap between the ruler and the curve on either side is about the same. So maybe like that, and then we can draw the tangent on. Okay, so let's draw a line on for the tangent. Okay, so what we want to then work out is how steep that line is. So it's a good idea to have 2 points that we can easily read off of this graph. So if I take this point up here, this is the coordinate 0, 100, isn't it? 0, 100. And this point down here, this is the point 2.50, isn't it? Okay, so then the gradient at that point, so gradient m is going to be change in y, y2 minus y1, divided by change in x, x2 minus x1. In this case, y2, the second y coordinate is going to be 0, minus the first is 100, divided by the second x coordinate, which is 2.5, isn't it? Divided by the second x coordinate, which is 2.5, minus the first, which was 0. So we've got negative 100 divided by 2.5. 2.5's into 100. Well, 5's into 100 go 20 times. It must be 40, mustn't it? So it's going to be minus 40 centimeters per hour. Okay, so at that point it is changing at a rate of 40 centimeters per hour. Okay, so what was his estimate? So using gradient of tangent at 11 a.m. gives, well, we made it 40 centimeters per hour. So is this estimate reasonable? Well, it's not a million miles off, is it? It's not that bad. I would say it's reasonable. 45 is a reasonable estimate. You know, reasonable is like within one significant figure, isn't it, of the true value. So if I'm getting 40, he's getting 45, that's pretty similar to each other. I'd say that's okay. Question 13. There are 5 blue sweets, 3 red sweets, 2 green sweets, and no other sweets in the box. Waleed chooses 3 sweets at random from the box and puts them in his pocket. Waleed calculates the probability of choosing 3 red sweets are 3 over 10 times 3 over 10 times 3 over 10, which is 27 over 1000. What incorrect assumption has he made? Well, he's made the assumption that this is probability with replacement. So if you look, his probabilities are the same all the way through. 3/10, 3/10, 3/10, which is not correct, is it? Because if you take a sweet out, then you've got one less sweet, which is red, to pick from in the second one. So these 3s will be going down each time. And also the number of sweets overall is going to go down each turn. So what assumption has he made? He has assumed the sweets are replaced after each selection. Okay, show that the probability of Walid choosing 3 sweets of the same colour is 11 over 120. So the probability of 3 sweets the same. Now that is the probability of 3 red sweets, isn't it? Red, red, red. Plus the probability of 3 blue sweets, blue, blue, blue. Plus the probability of 3 green sweets, green, green, green. Okay, so what's that then? So the probability of red, we said that you've got 1 less sweet on each selection, so it's not 3 times 3 tenths, 3 tenths, 3 tenths. First one is 3 tenths, so 3 red sweets, there are 10 sweets altogether. But on the second selection, there's 1 less red sweet, and there's 1 less sweet. And on the third selection, there's 1 less red sweet, and there's 1 less sweet altogether. So it's 3 over 10 times 2 over 9 times 1 over 8. Then blue, we start off with 5 blue sweets. So I'm going to get 5 over 10 as for the first selection, and then 4, and then 3 on the top, and 9 and 8 on the bottom. Now with green, we've only got 2 green sweets, haven't we? So 2 over 10. So then I'm going to get 1 and then 0, aren't I? There's no third green sweet, so actually it's not possible to get 3 greens. I'm going to multiply through by 0, that's going to cancel each other out, isn't it? So that's going to disappear, that bit, because it's not actually possible to pick 3 greens, which is the same as multiplying through by 0 gives you 0. So we've just got the first 2 bits to work out then. What's 10 times 9 times 8? 10 times 9 is 90 times 8. 9 8s are 72. So 720, isn't it? So I've got 720 on the bottom. 3 times 2 times 1, that's 6. Plus, I'm going to have 720s again on the bottom. 5 times 4 times 3. 5 4s are 20 times 3 is 60. So 6 7/20ths plus 60 7/20ths. That is 66 over 720. Okay. Question 14, part A. Write 7/11 as a recurring decimal. Okay. So we need to divide 7 by 11. So I'm going to do it by short division, I think. 7. I'm just going to make it 7.0000 so we can get an idea of what the pattern is like. So 11s into 7, they don't go, do they? So that's going to give me 0 up there. And I'm going to carry the 7 over into the next column. So 11s into 70. Well, 6 11s are 66, aren't they? So it can go in 6 times. And then the remainder is going to be 4 then, isn't it? Okay, 11s into 40. Well, 3 11s are 33, so it goes in 3 times. Remainder, well, 33 from 40 is 7. Okay, and then we've got 11s into 70 again, so that's going to give me another 6. And then after that, it's just going to be bouncing between 6 and 3, isn't it? 6 3 6 3 6 3 and so on. Okay, so we've got the pattern now, so we can then write that down as a recurring decimal. So it's going to be 0.63. The pattern starts here, stops here. These are the 2 ones that are repeating, aren't they? So 6 3 6 3 6 3. It's like that. B, convert 0.36 reoccurring into a fraction, giving your answer in its lowest terms. Okay, so now we've got 0.36666. Just going to write that down. Okay, so I'm going to write x is equal to 0.366666 and so on, an infinite number of 6's. So if x is equal to 0.3666, then 10x, that's going to be 3.666666 and so on. And 100x, just add in another, I'm multiplying that by a factor of another 10, is going to give me 36.666666 and so on. Okay, So then if I subtract 10x from 100x, it's going to leave me with 90x. And I hope you can see that if I subtract 3.6 reoccurring from 36.6 reoccurring, then my recurring decimally part is going to disappear from both, and I'm left with 36 subtract 3 then, aren't I, which is what's going to be 33. So that means that 90x has got to be 33. So x, just dividing both sides by 90, is going to be 33 over 90. Okay? Question 15. The histogram shows information about the times in minutes that trains arrived late at a station in one day. So we've got on the y-axis we've got the frequency density, which is trains per minute, and then on the x-axis we've got time in t minutes. David says that the range of times that these trains arrived late is actually 48 minutes. Could he be correct? Well, he could be correct, couldn't he? Because we've just got these this information grouped, haven't we? So we know that some trains arrived between 30 and 50 minutes, but we haven't got the precise times. So it could be that they've just got grouped together. So someone was standing on the platform with a clipboard and had 1, 2, 3, 4, 5 entry spaces, and we're just ticking the trains into one of those 5 boxes as they were coming in. So yeah, that's well possible. Could he be correct? We could say he could, as the data has clearly been grouped. Right, part B says 10 of these trains were between 30 and 50 minutes late on that day. Work out the number of trains that were at most 15 minutes late. 10 of these trains were between 30 and 50 minutes late on that day. Work out the number of trains that were at most 15 minutes late. Okay, so we know then in this histogram that this bar down here was worth 10. Okay, so it's the area of a bar which is proportional to its frequency in a frequency density histogram. So if you look along here, this is of a width of 20. So what would I need to multiply that by to get 10? It would have to be a half, wouldn't it? So on my scale here, this frequency density should read 0.5, which means it's 1, 1.5, 2, 2.5, 3, 3.5. So that's what my scale should be. Okay, now I know the scale, and I can answer the other part of the question, which was work out the number of trains that were at most 15 minutes late. So at most 15 minutes late, we're talking about this bar then and this one together. So these were the trains that were at most 15 minutes late. So we need to know the frequency of these two trains. So the first bar, you can see it's got a height of, well, that's got to be 2.1, isn't it? 2.1 times 10 along the bottom. So that means that equals 21 trains in there. And the second one has got a height of 3.2. 3.2, and I'm multiplying that by a width of the bar of, what's 5 this time. So 5 times 3.2. 5 3s are 15, 5.2s is 1, so that's 16 trains. Okay, so how many trains were at most 15 minutes? It's going to be 21 plus 16, which is 37. So 21 plus 16 equals 37 trains is my answer. 37. Right, question 16. Sarah buys X apples, Y oranges. She buys at least 4 apples, at most 9 oranges, and more oranges than apples. One of the inequalities for this information is X is greater than or equal to 4. Write down the 2 more inequalities of this information. Well, this inequality is clearly this one here, isn't it? At least 4 apples. X is greater than or equal to 4. So my oranges at most 9, this one here is going to be y, because y is the oranges, is less than or equal to 9. And then more oranges than apples. So y is oranges and x is apples. So the y has got to be bigger than the x. Okay? So that's strictly bigger than, not just, it can't be equal to x. They're more oranges than apples. Okay? So they're my 3 inequalities. Now on the grid, show that the region represented by these 3 inequalities in part A shade your region that is not required. Okay, so I'm going to draw the lines to start off with. I'm going to draw the lines x equals 4, y equals 9, and y equals x. Okay, and the way I'm going to draw these lines is because x is greater than or equal to 4 and y is less than or equal to 9. They both include the end values. So I'm going to draw these as solid lines. But y equals x, y is strictly greater than x, so the line itself is not part of the solution. So I'm going to draw that one with a dotted line. Okay, when I draw them on the graph. Okay, so let's draw those on. So x equals 4. That is a vertical line through x is equal to 4. So that's x equals 4. And I've got y is equal to 9. That's going to be a horizontal line through y is equal to 9. So that's, oops. So that's y is equal to 9. And then y is equal to x. That's like the 45-degree angle one, isn't it? Through the origin. Okay, and now remember I said I was going to draw this as a dotted line, broken line, because y equals x is not actually a solution to my problem. Okay, and now the last part, I wanted me to shade it, didn't it? The bit that I don't need. Okay, so if x is greater than or equal to 4, then I don't want the area where it's less than or equal to 4, so I want to get rid of this bit. Okay, if y is less than or equal to 9, then I don't want a bit where it's more than 9, so I don't want this bit here. Okay, and then finally I want y is greater than x. Okay, so which side of the line do I want? I want the coordinates where the y coordinate is bigger than the x coordinate. So is it this side or is it this side? Well, at this point I've got the coordinate what's that, 6, 8, and this point down here, that's the coordinate 6, 4. So where is the y coordinate bigger than the x coordinate? It's going to be 6, 8. 8 is bigger than 6, and not down here. So I want the side inside that triangle, not outside. Okay, so I can get rid of the bit on this side of the line here. Just leave myself that region in the middle. That's where I can pick my values from. Okay. Apples cost 45p each and oranges cost 30p each. Sarah spends £4.5 on apples and oranges. How many apples and how many oranges does she buy? Now presumably these are the same apples and oranges. It's still Sarah, so I'm assuming all the other conditions must apply. Okay, so we need to pick up all the possible values are going to be all the possible whole number pairs that are still in my range. So like that point there is a possibility, and so on. Okay, so it has to be a solution that lies within this range, otherwise it's not going to work. And then I've got let's say apples was x, wasn't it? So if I multiply 0.45x and I add on 0.3y, and then that equals £4.05 then, doesn't it? That's what I'm trying to solve. So I'm trying to solve this x and y values, but using values that are possibilities in this range. Okay, so obviously, you know, if you've got one equation with 2 unknowns, there's an infinite number of solutions, but I can only pick from values in this triangle. Okay, so let's let's pick some values out and see how we go. It's probably the best idea to start with the extremities. Pick those first and then try those. So it can't be on that line, so let's kind of look at these values to start with. So 4, 9, 8, 9 and 4, 5, and see how we get on with those. So let's try the top left hand corner then, which is 4, 9. What does that give me? 45, 0.45 times 4 plus 0.3 lots of 9. What's that equal to? 45 pence 4 times, £91.80 and £2.70. £1.80 and £2.70. £4.50. That's too much, isn't it? Okay, so that's too much. Let's try the bottom left corner of my range, which would be 4. I can't have 4, 4. I can have 4, 5. Does that work? So that would be 0.45 lots of 4 plus 0.3 lots of 5. So that's £1.80 plus £1.50 then, isn't it? £1.80, £2.80, £3.30. That's too low. Okay, so I'm going to get rid of that point there because I haven't tried. I'm just going to leave the points on that I've tried. So it's going to be down here somewhere. I think it's going to have to be an odd number of apples, isn't it? So I can get that 5p on the end. Because if it's an even number, I'm going to end in 0. So it's going to have to be an odd number. So why don't I try 5? Why don't we try 5, 6. Let's try that value. So then that would be 0.45 lots of 5 plus 0.3 lots of 6. So 30p times 6, that's £1.80. 5 lots of 45 pence, that is £1.80, £2.25. £2.25 and £1.80. That actually works, doesn't it? That comes out to be £4.5. Okay, so it's that one. So it's 5 apples, 6 oranges. 5 apples, 6 oranges. Question 17, part A. Simplify 3 root 2 times root 6. I can simplify this 3 root 2 root 6. I can multiply these two roots together, and that will give me 3 root 12. Okay, but 12 has got a square factor. It's got a factor of 4, isn't it? So that's the same thing as 3 root 4 root 3. And then root 4 is 2. 2 times 3 is 6. So that's the same thing as 6 root 3. So that's my final answer. 6 root 3. 6 over root 2. I don't like to have denominators that are surds. Maths teachers find them a bit fugly, so we're going to kind of get rid of them. Multiplying root 2 by root 2 along the bottom is going to give me 2. On the top I'm going to get 6 root 2, and then you can see that I can cancel that 2 into the 6, give me 3. So my final answer is 3 root 2. And evaluate 16 to the power of a half. Well, power of a half is simply the square root of, isn't it? So the square root of 16, that is going to be 4. Question 18. Ryan is using the quadratic formula to solve an equation of the form ax squared plus bx plus c is equal to 0. After substituting the values into the quadratic formula, he gets x equals minus 3 plus or minus 3 root 5 over 2. Find a possible values, or find a set of possible values for a, b and c. Okay, so if you remember, the quadratic formula should be the form x equals minus b plus or minus the root of b squared minus 4ac over 2a. Okay, so we can work out a little bit about A, B, and C by comparing what we've got over here in this with the quadratic formula, and then seeing if we can match anything up. Now, first off, I can see that -3 at the beginning matches with the -b at the front here. Okay, so that tells me that b could be 3. Okay, and I can see that the 2 down here matches with the 2a, which would imply to me that a is equal to 1. So b squared minus 4ac, we know that should be 3 root 5. So comparing the root of b squared minus 4ac, and we think that is going to be 3 root 5. Question 18. Prove that the difference between two consecutive square numbers is always odd. Okay, so we need to do this algebraically if we're going to make a proof. So let's take a number n, and if we square it, then that's going to give us our first square number. Now, what would the next consecutive square number be? So let's say I had 2 and I squared it and I got 4. So 4 would be my first square number. The next square number would be one more than 2. It would be 3, wouldn't it? 3 squared is 9. Okay, and I would get that by taking my value n, adding 1 to it, and then squaring it. So my two consecutive numbers are n squared and n plus 1 all squared. Okay, so these are my consecutive numbers. Okay, n and n plus 1 all squared. Now we want the difference of these numbers. Difference in maths means subtraction, doesn't it? So basically what I'm doing is I'm taking one of these away from the other one of these. So the difference is going to be n plus 1 all squared minus n squared. That's going to be the difference, isn't it? Okay. Now let's have a look at that brackets. If I square something, I'm timesing it by itself, aren't I? So that's n plus 1, n plus 1. And then doing FOIL on that bracket, n times n, n squared. 1 times n is 2n. And 1 times 1 is 1. Okay, so that gives me n squared plus 2n plus 1. And then I've got that minus 1 from there. So that one and that one are going to cancel it out. And that is going to leave me with 2n plus 1. So the difference is 2n plus 1. So if you think about it, if you pick a number and you times it by 2, 2n is always an even number, isn't it? So then if you add 1 to it, you're going to get an odd number. So I'm going to say 2n is always even. So 2n plus 1 is always odd. Okay, that's it. All done. Question 19. The diagram shows circle x squared plus y squared equals 5. Mandy says that the point 2, 1.5 lies inside the circle. Is she correct? Okay, you must show how you decide. Okay, so we've got this point 2, 1.5. You know, I'm going to draw it there, but it might not be on the inside of the circle. Okay, now to work out if it's on the inside of the circle, the easiest way of doing it is to work out how far away it is from the center. Okay, now if we can work out this distance from the center to the point, we can then compare it to the radius of the circle, which we should know. What's the radius of this circle? Well, we can derive, or we can work it out from this number here. The equation of a circle centered origin is always the form x squared plus y squared equals r squared. Okay, so r squared, the radius squared in this case, is 5, which means the radius of our circle is going to be the root of 5. Okay, so we know that this distance here is root 5. So if we then find the distance between the origin 0, 0 and our point x, which is the point 2, 1.5, if we find the length of that line and it's greater than root 5, then we know it lies outside the circle. If it's less than root 5, we know it's on the inside of the circle. Okay, so we just need to use a bit of Pythagoras theorem here, work out that distance and that distance, and then use Pythagoras theorem to find the length. Okay, so I know that this value here is 2 and this one is 1.5. I get that from the coordinates. So then 2 squared plus 1.5 squared all square rooted. What's that then? So the length O, let's call it point A, length OA squared is equal to 2 squared plus 1.5 squared using Pythagoras theorem. 2 squared is 4, 1.5 squared, well 1.5 is 3 over 2, square it is 9 over 4, isn't it? Okay, so what's that then? 4 plus 9 over 4. Well, 9 over 4 is 2.2 1/4, isn't it? So that's 6 1/4. So I can see already it's lying outside the circle because I'm comparing this 6 1/4 with my root 5. So this, remember, this is the length squared. So this is bigger than 5, isn't it? So therefore it's going to lie outside the circle. So OA squared is greater than R squared. Okay, and therefore it lies outside the circle. Okay, part B says the tangent to the circle at the point -2, 1 intersects the y-axis at A. Show that the area of the triangle APO is 5 units squared. So P is -2, 1. So that is -2, 1. What do we want? We need the triangle APO. APO. So from P to O, let's just draw that line in. Let's just draw this triangle actually. So we want this triangle that comes from here and then from O to A, and then A back to P again. Okay, what sort of triangle is it? Can you see? Now OP is the radius of this circle, isn't it? And a radius and a tangent join at the point of contact are always at a right angle. So this is a right angle triangle. We already know OP. We know it must be the radius of the triangle. It must be root 5. Okay. So to find the area of this circle, basically what we need to do is to find the length AP then, isn't it? So if I can find this length here, then I've got the two sides of the triangle. I can multiply them together and divide by 2 to find the area then, can't I? Okay, so I just need to find the length AP. Okay, so let's find the length AP. So we've got this, got this, got this, got a right angle here, that's root 5, that's P, that's A, that is -2, 1. What's the coordinate of A? We just need the coordinates of A then, don't we? Do we know what that point there is? Well, we know that the x coordinate is 0. We don't know the y coordinate yet though, do we? Okay, now can we find that? I think what we're going to have to do is we're going to have to find the equation of the line AP, aren't we? If we know the equation of the line, then we'll know what the y-intercept is because it will be the c value of that equation, won't it? Okay, so what I want is the equation of the line AP. Okay, now in order to find the equation of the line, I need either 2 points on the line, which I don't have because I don't have the point A, or I need the 1 point, which I have, and the gradient. Now I don't know the gradient of the line AP just yet, but I do, or I could work out the gradient of OP, and I can use the fact that that is perpendicular to the gradient that I want to then find out what the gradient of AP is. Okay, so we're going to find the gradient of OP first. So O is the point 0, 0, isn't it? So the gradient of OP, let's call it M1, that's going to be the change in Y, so Y2 minus Y1, so let's call this X1, Y1, and this X2, Y2. So the gradient is change in Y, Y2 minus Y1 over X2 minus X1. So that is Y2, which is 1 minus 0, divided by X2 minus 2, subtract 0. So that's going to be negative a half then, isn't it? So that equals minus a half. Okay, so then the gradient of AP is going to be negative reciprocal of that then, isn't it? So you flip it over and you change the sign, so it's going to have a gradient of 2. Okay, so we know the gradient of this line AP, and we know a point that it goes through, minus 2, 1. So equation of the form y equals 2x plus some unknown value c, which we're going to find. So we know it's the form y equals 2x plus c because we know the gradient is 2. So then subbing in the point that we know, so substitute the point in, minus 2, 1 into equation. And that's going to give me 1 is equal to 2 lots of minus 2 plus c then, isn't it? So 1 equals minus 4 plus c, so c then is going to be 5. Okay, so now I know 5, so we know this has equation y equals 2c plus 5. Now that 5 is the y-intercept then, isn't it? Okay, so that means my value up here for A is now known. We now know it is 5. We found it. Okay, now we know that value, we're making some progress. So now we can work out the length AP. And once we know the length AP, we can work out the area. Have we got some more paper? They give us a lot of space to work this out, do they? Okay, we're running out of space down here. I'm going to go back up here and do some working up here, I think. So we've now worked out that this point up here is 0, 5. We want to work out the length of this line here, don't we? Okay. So we're going to use Pythagoras theorem using the coordinates of P and A to work it out. Okay. So if we call this one x1, y1, x2, y2, then I have an equation of the length of the line. So the length AP squared is equal to change in y squared, so y2 minus y1 all squared, plus change in x all squared, x2 minus x1 all squared. We're just applying Pythagoras theorem to the coordinates, aren't we? So y2 minus y1, that's going to be 5 subtract 1, so 5 subtract 1 all squared, plus change in x. So we're going from minus 2 to 0, so 0 subtract 2, 0 subtract negative 2 all squared. Okay, so that's going to give me 4 squared plus 2 squared. So 16 plus 4, that's 20. So that's root 20. So AP is root 20. Okay, so we now know that length of AP is root 20. So we know both sides. We've got root 20 and root 5. So we should then be able to work out the area of the triangle. So coming back to here, we can squeeze it in here. Area of triangle. So that we said was root 20 and root 5. So area is equal to a half base height, which is a half times root 5 times root 20. So what's that? Root 5 times root 20 is a root 100. So half root 100. Root 100 is 10. Half of 10 is 5. Okay, well that was a lot of work, but we got there in the end, and it was worth 6 marks. So the area of the triangle APO is 5 units. Okay, so we did it. Hurrah and huzzah. Question 20. OABC is a square. The vector O to A is vector A, and the vector O to C is B. M is the midpoint of AB. L is a point on MC such that LC equals 2ML. Use the vectors to prove that the line L lies on the line OB. Ooh, that's quite confusing, isn't it? So what do we know? So we've got our two vectors O to A and O to C, which are clearly marked. So there's my vector A, and there's my vector B. So I want to use vectors to prove that the point L lies on the line OB. Okay, well what is the vector O to B to start off with then? To prove that it lies on OB, we need to find out what OB is. So the vector O to B then, what's that? O to B, the vector O to B. Well, if I want to get from O to B, I need to go along B and then across A because it's a square. So I know that CB is going to be the same thing as OA. So I can say that O to B is the same thing as O to C plus C to B, and that is the same thing as O to C plus O to A because it's a square, which is simply B plus A, isn't it? Vector B plus vector A. Okay, so far so good. So we found this line running through the middle is, and we've called it vector A plus B. That's A plus B. Okay, and then let's have a look at the other one now, M to C. What is M to C? So we can see that M to C then is equal to M to B plus B to C. Now M to B is going to be half B, isn't it? Okay, because M is the midpoint, and B to C is going to be minus A. Okay, so I've got half B minus A is my vector from M to C. Now we're told here that L is a point on MC such that LC equals 2 lots of ML. So the distance between L and C is twice the distance from M to L. So for every 1 you've got here, you've got 2 on this side, haven't you? Okay, so then the distance from M to L then is going to be 1/3 of the distance from M to C then, isn't it? Does that make sense? So M to L is going to be 1/3 of M to C. Okay, we've already worked out what MC is. It's half B minus A, isn't it? So that's equal to 1/3 of a half B minus A. Okay, removing the brackets, that is 1/6 of B minus 1/3 of A. Okay, so that's my ML. Now, so what is O to L? So if I wanted to start at the origin and wanted to get to L, going along things I know. Now I know O to A, it's just A. A to M is half of B, and I've just found M to L, it's 1/6 of B minus 1/3 of A. So I can get to from O to L via that route around the edge. Okay, so that's what I'm going to do. I'm going to work out what OL is in terms of those vectors. So going along vector A from O to A, it's O to A plus A to M plus M to L, isn't it? Okay, so we know O to A is A. We know that A to M is half B. And we know M to L now is 1/6 of B minus 1/3 of A. Okay, so what's that? Just collecting like terms, I've got an A minus 1/3 of A. So that leaves me with 2/3 of A. 2/3 of A, and I've got a 1/6 of B and a 1/2 of B. So 1/2 plus a 6, what's that? 1/2 plus a 6 is, well, 3/6 plus 1/6 is 4/6. 4/6 is the same thing as 2/3. So I've got 2/3 of B as well, haven't I? So I've got 2/3 of A plus 2/3 of B. And now you'll see that they've both got 2/3 in common here. So I can take out 2/3 as a common factor. So it's 2/3 of A plus B then, isn't it? But I recognise A plus B. I wrote it down earlier. That is just O to B, isn't it? O to B is, well, I wrote B plus A, but it's the same thing as A plus B. So that there has got to be the same thing as O to B. So O to L is actually 2/3 of O to B. Okay, so if it's 2/3 of O to B, then it must lie on the line OB then, isn't it? Okay, if it's a scalar of O to B, it must be on the line OB. So therefore, L must lie on OB. Job done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.